All right. So I came here to talk about networks, hierarchies, and the Vingean Singularity. And the basic idea that I wanted to point out was there's this field of complexity studies which has been very interesting for the last 25 years and has attracted a lot of very smart people to work on what look like low-hanging fruit for developing the physics way of doing research in to applying it to practical questions, such as how do societies grow and fail, how do cities work, how do economies really work, and the like. And I think that they've generated a lot of useful information. There's this other field that started about the same time called transhumanism, which you guys have probably heard about. Or really, back originally it was called extropianism. Now, thinking about the two fields, I noticed that something that I could call the fundamental non-mathematical theorem of transhumanism is work around complexity. You could say that basically the point of complexity is that there are lots of systems that as the number of subsystems grow, the complexity grows exponentially or even faster than exponentially, so that computational modeling doesn't help very much. Algorithms can give a multiplier of the efficiency of your computation, but exponentially crushes multiplication. Moore's law gives exponential growth in computing power, but that only gives linear results. And honestly, linear results in a year and a half are just not that great. So when you think about a lot of the most prominent transhumanists, such as Ulrich Gray, who's here, and Eric Drexler, who's no longer here, who's not here right now, you can just characterize their work as saying, here is a complex thing, life or an ecosystem or an economy or a manufacturing system. How can I make something non-complex that does the same thing as this complex thing, but which humans can understand and therefore make work better? So a few general things you might want to look for is first, do I think it's possible? Do I think it's probably possible to find a non-complex alternative? A general heuristic there, you can look for scaling laws. If you can think of things with a lot of parts as being either complex or hierarchical. Hierarchical systems have well-defined or fairly well-defined layers, which can be treated as black boxes, nested in other black boxes, nested in other black boxes. The information processing within the black box doesn't matter. Each one can be treated as taking in certain inputs and providing certain outputs. In a complex system, the information processing can't be treated as being encased in boxes. The information processing belongs to the whole system. So flipping a switch in your piece of software, 1, 0, turning it into a 1, can make an error and make the whole thing crash. A general rule to start with is evolution can't build complex systems. This may seem surprising because we seem to be complex, but so is the weather. A cloud is complex. The complexity in living things all just comes from the interactions of small parts. You know, the complexity is, word my founder Eliezer would disapprove of, emergent from the interactions of the small parts, but it isn't actually created by the evolutionary process that creates the living system. Now, it's conceivable that that complexity needs to be there, that you couldn't build a system like a human out of parts that were not full of all sorts of interactions from which high-level patterns could emerge. But it's not conceivable that the complex interactions were built in because what evolution is doing mathematically is fairly well understood. You know, basically, it's doing something much simpler, less powerful than simple statistical algorithms, strictly less powerful than statistical systems that we can define rigorously and show not to be able to solve hard problems. Since evolution can't build complex systems, this suggests that there should be simple, therefore tractable, analyzable, understandable ways of doing the major things that matter to us, because basically things matter to us because we're evolved systems, the sorts of things evolution does are the things that matter to us. Thinking, having fun, eating well, reproducing, living longer, being healthier, all of these things can clearly be done through evolutionary design. Our brains are built that way, our bodies are built that way, etc. So let's talk about the specific examples. Aubrey's proposal, SENS, basically consists of, okay, you've got this impossible, intractable diagram of metabolic interactions. Okay, well that's not something science will work on. You can't gather exponential amounts of data on biological interactions. You can't do exponentially complex computations. You can just ask, what are the simple things that are going wrong? You know, if I was basically evolution, if I was trying to increase the life of a tree shrew, 1 year life expectancy, to the life of a vampire bat, same general body mass, 25-year life expectancy, what important differences would I find in the vampire bat? Well, certain things have to not build up, certain things have to not run out, etc. That, in a nutshell, is sense. The engines of creation is basically, wow, it would be great if we could build machines that worked like biological systems, and because biological systems can build with so much complexity and so cheaply, etc. Okay, well, we can't understand biological systems, but if the biological systems aren't doing anything that a hierarchy can't do, then let's figure out hierarchical manufacturing systems that can produce the same sorts of products as biological systems. Let's put all sorts of constraints on the space of hierarchical systems that we're going to examine so that we don't bog down in the complexity of things that we're going to examine. And by narrowing down what options to consider, say by only looking at carbon-carbon bonds, find something easily tractable that does really cool stuff. Another good general rule, other than evolution can't build complex systems, is that complex systems are likely to scale more than linearly, while hierarchical systems are likely to have redundancy and to throw out information at each level of the hierarchy, and therefore scale less than linearly. So a great example of a truly complex system is a city. You can look at the GDP growth rate, or the amount of crime, the speed at which people walk, and the speed at which people eat, the amount of traffic, and the energy consumption. And all over the place in cities, you end up with 1.1/5 power laws, where you have basically increases in the efficiency of different processes as the scale increases. And this is due to division of labor, etc. That doesn't sound like the sort of thing that results from throwing away information and redundancy. On the other hand, when you look at life expectancy, you find a 3/4 power law. As the mass of an organism gets greater, it lives longer because the metabolism is lower relative to its size. And the organism with its lower metabolism, God, I'm badly sleep deprived, and I just got a 10-minute warning. So okay, the metabolism is lower. Basic point: life expectancy scaling less than linearly with size is evidence of not a complex system. Therefore, the sort of thing that we could look for a way of doing science and solving. But it still isn't going to help to know that the system isn't complex. You have to actually work around the complex parts, not try to understand all of these biological networks, but merely understand the information processing systems that could have found order, like Michael Rose's thing, using evolution to find ways of building long-lived flies, etc. Anyway, I think the place I was going here is the Vingean Singularity. It seems to me that the basic idea Werner Vinge was proposing when he suggested the singularity was that once humans are no longer the smartest thing around, we won't actually be able to guide society, and we won't be able to see where society is going. And one of the things that could be smarter than humans is, ironically, groups of humans. So, as I said, cities are already a complex system that divides labor and in many ways acts smarter than humans do. You can definitely and fairly easily imagine using information technologies to allow people to cooperate more efficiently, divide labor more efficiently. And at the far end of that, you get the sort of world depicted in Nick Bostrom's essay, The Future of Human Evolution. That sort of world isn't guided by human values, even if it's initially only made up of humans. Even if it's ultimately only made up of humans, you can have a world where people are dividing labor in extremely fine-grained ways and pursuing efficiency-type goals, which are not in any way optimizing for humans getting what they want, but are produced by the selective pressures of competition within an economy which, unlike evolution, is able to look ahead, see that something's inefficient, and weed it out preemptively, rather than allowing the inefficiency to continue going on. That sort of a situation is a very easy way to imagine the problem of unfriendly AI, which the Singularity Institute tends to be focused on building. Here I'm basically describing an unfriendly AI composed entirely of people. The author Charlie Strauss, in his book Accelerando, calls basically that sort of scenario vile offspring. And I think that will probably be the standard term for it, because science fiction tends to do that. I guess Paul of hands, has anyone read Accelerando? How popular is it? Okay, so it's about a third or a fourth of the group. All right. So for the rest of you, basically Accelerando is a group of short stories that were kludged together into a novel, illustrating the idea of accelerating change towards and past the singularity. If you just don't worry about that term, past the singularity, because it sort of violates the idea of unpredictability and doesn't look anything like what I would imagine a post-singularity world to look like, I would say it's a worthwhile illustration of a hugely dense, packed clump of singularity and transhumanist-related ideas in a bite-sized, flavorful portions. Anyway, the basic idea that we've been pursuing when we talk about friendly artificial intelligence, that is we, the Singularity Institute, is trying to figure out how to make the sorts of things that humans want well-defined and tractable, so that we don't have complex systems optimizing for alien measures of efficiency and can go on doing the things that we want, rather than the things that the logic of local interactions causes basically the universe to want. Because even if a cloud is incredibly difficult to make, that doesn't mean it's incredibly valuable to us. It's complex, it's maybe pretty, but I just don't think it's worth spending an infinite amount of money for a perfectly precise cloud, or an infinite amount of money for a perfectly precise model of the human body's biology, when we can focus on things we actually want, like water or aging, focus science on those, and build the sort of world we actually want. I'll open to questions.